This is Chapter 4 practice test number 6. We have a 10 kilogram box sits at rest on a board that makes an incline of 20 degrees to the horizontal. I'm going to go ahead and draw a picture of that. This is supposed to be 20 degrees, although that's a little steeper than 20. We're going to pretend. And we've got a 10 kilogram box. It's at rest right now. If the coefficient of static friction between the box and the board is 0.45, mu s equals 0.45, find the magnitude of the force of friction on the box. Okay. There it goes. Okay, so let's do a free body diagram first. Now this is one I gotta tip it. Yes, you have to tip it. Oop, I didn't do a very good job of that one. Let's try this again. There we go. I'm gonna make, doesn't really matter. I'm gonna make up the slope positive. It really won't matter. Oops, that's supposed to be an x though. There we go. Make this positive y and that negative y. And this thing is a 10 kilogram box. Okay, let's look at some forces on this thing. So, I've got the weight of the box down, which in this case is 10 times 9.8, or 98 newtons. I'm going to have the normal force perpendicular to the board. I don't know what that is yet. Leave it alone. And then I've got friction. So it says it's at rest to start with. If there was no friction, this box would slide down the ramp. So friction is going to counteract that possible motion. Friction will be up the ramp. So like this. Don't know how much yet though. Okay. The first thing I need to figure out is how much friction is required to hold this thing at rest. Okay, so to hold this thing at rest, I would say F net in the x direction equals ma. To hold this thing at rest, I need ma to be 0. I need a to be 0. Okay, if this is going to be at rest, a will be 0. In the x direction, I've got friction up the slope. Down the slope, I've got the x component of gravity. I've got this. Okay, and that's going to be 98. Here's my theta. That's my 20 degrees. I should put 20 in there. In the right color. If I'm going to use different colors, I should color code. Okay. This is opposite the 20 degrees, so it'd be sine 20. Okay, so F net minus 98 sine 20 equals 0. Alright. Thing is, that's it. So the friction I need for this to stay at rest is 98 sine 20, or 33.5 newtons. But do I have that much? Do I have that much friction? We need to check. To check it, I know that friction max, and you know what, I know maximum static friction is mu s times the normal force. Okay. That is 0.45 times the normal force. What is the normal force? We need normal force. So, normal force, I'm going to figure out by doing F net again, but in the y direction. In the y direction, I've got normal force up, and I've got x component, or sorry, y component down. That's going to be adjacent to the 20 degrees, so it's going to be 98 cosine 20 equals, again, acceleration would be 0 in this direction. Actually, no matter what, because it can't go into the block or into the wood and it can't float away. So what I end up with is that normal force ends up equaling 98 cosine 20. Ooh, just dropped my calculator. Which is 92.1. Okay, I'm going to put that over here. And what I get is that the maximum friction that could exist here between this block and this board is 41.4 newtons. Okay, so we compare. This is what I need. This is what is available. Is this enough? Yes, it is. So, this is possible. This friction is, in fact, possible. And so that would be the answer. If we had done all this, and we had found that F max was less than the friction necessary, the friction at this precise moment would be the maximum friction. But the next infinitesimal slice of time, that box would have started sliding, and we would have had to switch to kinetic friction. Okay? But because the friction we needed is less than the maximum friction, we're good. We just stop there. We're good. So points. This is the answer. I can give you a point for the answer, a point for the unit, okay, a point for F net x equals ma, a point for saying that the acceleration is 0 somehow, either putting a 0 in there or doing that little cross it out and point to 0 thing, a point for getting these correct. Okay, so 1, 2, 3, 4, 5. A point for getting the correct, like it's a sine of 20, like the correct interpretation, or not interpretation, that's a stupid word for this, the correct trig function. Okay. Note that 98 cosine of 70 would also be acceptable. Okay. Okay, a point for this equation showing, a point for this equation showing up somewhere. Sorry, my thing's being weird. What are we up to now? 1, 2, 3, 4, 5, 6, 7. Okay. How about a point for calculating the normal force somewhere? It just shows up. Either it just shows up here or it shows up over there or whatever. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, we need 2 more. How about plugging this in? 9. And getting this, 10. Okay. Yeah, that's 10, right? 1, 2, yeah. Okay.